Hello, can you hear me?
Yes, sir.
Okay, and also see my screen.
Yes, sir.
Okay, so did you solve last problem in on inverse of the matrix? Inverse of the matrix. So, anyways, you try it on your own. If you have not tried, we can discuss it in the next class. So, error analysis and system condition. Okay, so there are methods that can indicate ill conditioning. We have already seen what is ill condition system. Uh, we in condition system is this something two equations, two unknown. We have seen this type of equation. Here we have made a change in this uh, value of this first coefficient. There were two solutions. X1 is equal to 1 by 3 and x2 is equal to 2 by 3. And through pivoting, we got this exact solution. So we have seen this type of system was a ill condition system without pivoting. Now we see this before performing any this calculation, there should be method that we should able to check that whether the system is ill conditions or it is a perfect system. So vector and matrix norms. So norm is a real valued function that provides measure of the size or length of multi-component mathematical entities such as vector and matrices. Okay, so norm is a real valued function that provides a measure of a size of length of multi-component mathematical entities such as vector and matrices. So we will see what is this norm all about. A simple example is a vector of three-dimensional Euclidean space that can be represented by this representation. So if you have a vector a I cap B, A j cap, and C cap, so magnitude is represented by A square plus B square plus C square, and we take under root of this. So length of a vector, we all know this, it can be computed using this formula, and this indicate the Euclidean, this length is referred as Euclidean norm. This is for this vector. We are not dealing with vectors, so we are dealing with basically matrices. So here we have seen that we have made a square all the terms of the vector and taken under root of that. So for the similarly, we can compute to perform this exercise. Make all the coefficients a11, a21, and a31. Similarly, b12, and all the coefficients like this, and make a square and take the root of this. So vector, there is an alternative called p norm. So we are not dealing with vectors. So here we see this matrix. Here we see matrix. There are norms. What is this norm about? So suppose that we wish to calculate this norm of a vector. So norm of a matrix. So here what we do is that we perform the summation of absolute value of coefficient for each column, and the largest of these summation is taken as norm. This is called column sum norm. So what we do is that we do summation of a coefficient of or absolute value, not negative value, positive value, mod. So all the positive value is taken and simply add all the columns and the sum of the highest sum of the column is called as column sum norm. If we perform this the same exercise on a matrix, that is, we take absolute values of each row and add up and take the highest value, we call it as a row sum norm. So one thing is to notice is that it is given by this double line, and one we this place this as a subscript as one. This is called as column sum norm, and when it is replaced by subscript infinity, we call it as row sum norm. So let us quickly calculate or solve one problem. Here, one another norm for this vector is for matrix is Frobenius norm. And what is this Frobenius norm? Is that we may square all the coefficients and take the under root, and this we call it is as Frobenius norm. So there are three norms. That is, one is Frobenius norm for the matrix, one is a column sum norm, and one is row sum norm. So we will see what is the advantage of these calculating norm. So let us see this matrix. This is called as a Hilbert matrix, and this is a ill condition system. Ill condition system means that if we make change in any of the slight change in any of the coefficient, then a large change in the Fourier solution is observed. So here we can see this is a n cross n matrix. So if we take only 3 cross 3 matrix from, if we extract only 3 cross 3 matrix from this Hilbert matrix, so this is 3 cross 3 matrix. You can see here this. So we need to determine the row sum norm of this matrix. Row sum norm is need to be calculated for this. So you observe first row, second row, and third row of this matrix. So if you add first all the elements of this coefficients of all the numbers of first row, then you will get 1.833. Similarly, if you add all the numbers of this second row, you get 2.1667, and if you add all the coefficients of third row, you get 2.34. This third row has largest sum, so you can see 2.35 is the highest value which is obtained from the third row, and row sum norm is 2.35. So since it is a row sum norm, you can see here this that we are representing it by double line and with the infinity sign. So this is a row sum norm. If it was instead of infinity, if we replace this with 1, then it will be a column sum norm. The inverse of scale matrix can be computed as, so if you compute the inverse of this matrix, we will get this term. Now this is inverse of a matrix. Now one more term we are introducing is condition number. So if you want to identify the condition number, so what is the method is that we have determined the row sum norm, that is 2.35. Similarly, we will calculate the row sum norm of this matrix, that is A inverse matrix, by taking only absolute values, and the highest value is if we add up all the threes, these those R1, R2, and R3. So R2 will give us the highest magnitude, which is 192, and in order to compute this condition of a matrix, what we do simply is that we multiply with this row sum norm, which was this 2.35, and throw some norm of this matrix A inverse, and we get some value for 451.2.
Sir,
Please tell Ayush.
sir, in the sir, when we are finding the row sum for A, we are
Hmm.
normalizing the first column. But when we
Yes.
are going for the row sum of A inverse, we are not doing that.
Wait for the minute. This is means this is
Yes,
this
sir.
is what?
Here a normalization of the first column is done.
Okay.
Yes, but in the next part of A, finding the row sum of A inverse, we are not doing like that.
Please wait. Eh, please wait. Let me look. Have a look at this. Mm, we are wait. Please wait. Normalizing means this. We are making all the first matrix can be normalized so that maximum element in each row is 1. Okay. So please wait for a minute. This is inverse of a scale matrix is this is 36, 96, and this. Okay, yeah, means we have to normalize this even also. Okay, so you normalize this also, and this is something I calculated it in a different way. So means point of saying is that when we calculate this condition number, so higher is the this condition number more than unity. If it is too large than unity, then it is called as highly yield condition system, and the extent of yield condition is obtained by taking log of this value. So we are not means interested in taking calculating the strength. Means condition number should be close to 1, then only the system is not ill condition. Okay, so I will have a look on this what you said this.
Yes,
Then
sir.
we
Sir,
will.
even if we are finding column sum norm, then should
Okay.
we normalize the first row?
Yes.
Yes, sir.
No, not first row, your column na.
Sir, if we are finding a column sum norm, sir.
So here you have normalized the row na. Here you have normalized this row for this wait for a minute. Means column some row some norms we have seen this here, row some norm. So please have a look on this row some norm. So this is was this highest of row some norm was we calculated it as this wait for a minute. So what we have written is that summation of absolute coefficient is performed for each column, and the largest of these summation is taken as norm. Okay, so we have not normalized here this. Ayush, what is your question?
If is here we are finding a row sum norm, suppose we are finding column sum norm, then we have to normalize the first row. Here we normalize the first column. So if it is opposite, then we should
Okay,
normalize the first row. Yes, sir.
Ayush, please have a look on this formula. Okay, so here we have not this normalized this, but in order to calculate the condition number, we have not have normalized that part only. Okay, so please have a look on this. We are simply adding these terms. You see here that here we have simply added all these terms, not performed any exercise. Here we have normalized for some purpose. Okay, I will discuss it later. So here if you have a look on this formula, we have simply adding all the rows, absolute values of all the rows, and here in order to calculate this absolute value of all the columns, and this in order to calculate row sum norm, we are adding all the absolute values of all the columns and we take the maximum value of that. Okay.
Yes, sir.
ठीक है ये I will discuss this A inverse example this in next class. Okay. So Gauss-Seidel method was one of the method which was left for finding the solution of this system of equation. Okay, so the Gauss-Seidel method is the most commonly used iterative method. So assume that we have a matrix this A x into B. So if I want to know the this solution of x1, x2, and x3 for the 3 cross 3 system. So Ayush, can you suggest me what could be the what we take is that we assume x2 and x3 as zero value, and once we get the value of x1, so here we will substitute it in this equation 17b, the value of this x1, and x3 we have initially assumed to be as 0, and we get one value x2, and from there we this value of x1 we computed it from equation 17, and value of x2 we computed it from equation 17b. We will substitute it in equation number 17c and we will calculate the value of x3. Okay, so in a similar manner the process will go on iterating the value of immediate value of this x1, x2, and x3. We keep substituting on this, and we will get the value of next iteration until and we get the exact solution. So let us have a look of this method. How do we do this? So here we have one question. So the solution of this this three equations and three unknown is this x1 is equal to 3, x2 is equal to minus 2.5, and x3 is equal to 7. So by Gauss-Seidel method we can write this as a 19a, 19b, and 19c. So one immediate solution could be that if we do not know any solution, we can assume x2 and x3 as 0 and get the value of x1 as this 2.61 something, and x3 we have assumed to be as 0. So in equation 19b we will substitute the value of x1 as well as x3 and get the value of x2, and similarly we will substitute the value of x1 and x2 in equation number this 19c and get the value of x3. So once we get the value of your x1 and x2 and this x3, so we will substitute back in our in equation number 19a, 19b, and 19c. So we will see that this solution is closely means very much close to our exact solution, and the error in comparison to this true value is just 0.31% and 0.05% and 0.42%. Okay, so in second iteration you can see here that we have initially assumed x2 and x3 value as x1, x2, and x3 value as 0. So you put here the values of this x2 and x3 as 0. You get the value of x1 here. So now this updated value will be entered in equation number 9 for x1, and the initial value of x3 will be entered, which is 0, and we can calculate the value of x2. Once we get the value of x2, we again substitute the new updated value in equation number 19c and get the value of x3 as this uh, uh, this is 7.056. Okay, so this is x1, x2, and x3. So you can use these updated value in equation number 19a, 19b, and 19c, and only updated value are entered here. So here I show this process through a picture. Let me go to the one this schematic diagram. So here you can see here that these are the values of x1 and x2, and we only substitute the updated values here. Okay, in next equation in computation of next next value updated or the next iteration. So based on this, we will solve some formula, this numericals, and you if you know the exact answer, obviously you know the exact answer, you can calculate the percentage error with respect to two value, which is 0.31, 0.015, and 0.0042. This method is therefore converging on two solution. Additional addition could be applied to improve the answer. However, in actual problem, we would not know. In many cases, for the three cross system, it is known, but for this larger system of a five equations and five unknown, we cannot calculate, or it is difficult to calculate the exact solution. Okay, so this value can be very helpful there. So can you solve this problem using this Gauss-Seidel iteration method? This is called as Gauss-Seidel iteration method. Ayush, can you please solve this?
Yes, sir.
What is the exact solution for this?
Sir, 1 minus 1, 1.
Okay, 1 minus 1 and 1. So using Gauss-Seidel method, if you assume this y as 0 and z as 0, what you would get as x?
17 by 20.
Huh? Mrinal?
17 by 20.
Yes.
0.8.
Okay, okay. You perform the way you are doing. So if you substitute the value of z, that is assumed z is equal to 0 and updated value of x1 in this equation number 20b. What do you get? Okay, Ankit, okay. Z, what is Z now? Z, okay. Please carry this second iteration now with the updated value. Okay, first iteration you are getting these values and this Saurabh Kumar Gupta. Next, you perform next iteration. So on second iteration, you will get these values. So who got the correct answer? This is second iteration. After second iteration, okay, many of you got this. So similarly, if you proceed in this line, and after third iteration, you see that we are getting this value as x3 as 1, y3 as -1, and z3 as 1. Okay, so the solution is x1 is equal to 1, y is equal to -1, and z is equal to 1. Can you solve this question? Who can give me the exact answer for this? Next question. What is the value of exact answer of question 4? What is who can give the exact answer for the x value, y value, and z value for equation number 4? Now we will cross check our answer using this only Gauss Seidel method. What is the exact answer for this? Any one of you who can solve this three equations, three unknown system, and give the exact answer for this? No one? Ayush, what you are getting?
Sir, one thing is that in following the equations x, y, z,
Hmm.
the manner in which the equations are written has been converted. Suppose the second equation is x plus y plus 54z is equals to 110, but it
Hmm.
has been used for finding z, not y.
Uh, Means this the way you are saying. So I have written in this manner. You can write it on your own way.
Okay, sir.
Uh, no, but you gave the answer, exact answer for three system and this using your conventional approach. You solve it this making this y is equal to this 110 minus of this minus x and minus 54 z. You solve in that way, you will also get the same thing, na? So Ayush, what is the exact answer for this question? Or Ankit Sarkar, Abhijit Padasar?
Yes, sir. Doing survey.
No, do it means you first tell the exact answer. Three system, a system of the three equation and three unknown. You can easily solve it using your scientific calculator. No, you have to simple substitute these coefficients over there. The three class system, uh, three class three. This system can be easily solved using your scientific calculator. Who else can answer this? Banti Kumar Das, Bhavya Goyal, Dhruv Mehta, Ritik Roshan, anyone of you? So Ayush, did you solve this problem?
Sir, x1, sorry,
Mm.
x2, y minus z1.
You,
Z
you
y1.
type the answer in the comment box.
Okay, sir.
Okay. Ayush has given the exact answer as 2.42, 3.57, and minus 1.92
So plus 1.92.
plus 1.92. And what about Abhijit? Are you getting the same answer?
No, sir.
So Ankit is getting 2.42 and 3.57. Okay. Anyone else? What others people are doing? Only two and three people are answering. Amrit Shukla, Anshu Kumari, Astha Rani, Ashish Kumar. Okay, let me check who else is not paying attention. Kumar Abhinav, Rinal Bharadwaj.
यस सर
क्या है आंसर?
सर एक मिनट बता रहे हैं सर एक्स वाई का वैल्यू तक है एक्स वाई एक्स जेड निकाल रहे हैं
Comment box में you type your answer in the comment box.
यस सर
Only
यस
some people are Nitin Raj, Sachi Das, Rishabh, Sanjeev Kumar, okay, so we are working for the exact problem solution for the problem. So in first iteration, if we substitute this value as this x is equal to 0, y is equal to and z is equal to 0, you will get this 3.14, 3.541, and this is 1 point. These are the updated values. Again, we will substitute and compute the values of this x2. X2. Anything? Anyone wants to say something? Okay. So this x2 we will compute by substituting these values of y1 as 3.541 and z1 as 1.1913, and get the value of y2 as this 3 x2 as 2.432. This is now updated value of x2, and we will use the previous value of z1 here for computation of y2. Now these two updated value of x2 and y2 will be used in computation of z2. So similarly, we have performed this up to this fourth iteration, and we see this is the exact answer: 2.426, 246, 2. 4 2, okay, 6, and second is 3.573. 3.573, yes, you many of you are getting this correct. And last is z is equal to 1.926. Okay, so Ayush, what was the answer you are getting using means the approach you followed?
Yes, sir. Same. 2.42,
Uh,
3.57,
okay,
1.92.
okay, okay. So applied Gauss Seidel method to solve this. Can you solve this? Okay, you take it as your assignment. You solve it, and we will discuss it in the next class if you are not able to solve. But I'm confident you will be. You can easily solve this problem. But here you have a look on this that it is having four equations and four unknowns. It is no longer having three equations and three unknowns. So you solve this, and we will discuss the exact if you are not able to solve. But uh, I guess you will be easily able to solve this. So So you take this question as an assignment. I'm moving to our next topic because that need also be covered. So exact solution you may write here. Look here that this is x1 is equal to this 1, x2 is equal to 2, and x3 is equal to 3, and x4 is equal to 4. So you solve it on your own. If you are not able to solve it using this iteration method, Gauss iteration method, so I will discuss it in our next class. Okay, so next is Jacobi iteration method. Okay, so this is also pretty much simpler. In a previous approach, let me explain this with through a table systematic diagram. In figure B, you have a look on figure B. Here we do not use updated values of x1 and x2 and x3 for the calculation of next this unknown. Rather, we follow the approach that we calculate the value of x1, x2, and x3 based on our initial approximation. Suppose that we assumed x2 is equal to 0, x3 is equal to 0. So we will take these values, initial values of x1, x2, and x3 0 in for computation of this updated value of x1, x2, and x3. Similarly, we will perform this exercise for the next iteration. So let us proceed towards one example, and we will try to see this through a solve numerical problem. So here we can express this equation number 21 in by for x and y and z. So here you can see it in equation 23. These are updated values. Similarly, x2, y2, and z2 are the updated values. And here you can see solve by Jacobi iteration method. We are interested in finding the solution of this system of equation. So we can easily write this above system of equation as this in terms of x, y, and z. So Ayush, can you give this what is the value of your x, y, z if I take initial value of x, y, z as 0? Ankit, can you give the answer?
Sir, 0.85 minus
Uh,
0.9 and 1.25.
if you take all the values of x, y, z as 0 initially,
Yes, sir.
okay. So now the updated values of x, y, z are known to us. Now, if we substitute again the updated values of these x, y, z in equation number 25, what you are getting? So let us see this. As Ayush told that the x1 is 0.85, y1 is minus 0.9, and z1 is 1.25. Now these updated values of x1, y1, and z1 are again substituted in equation number 25, and we get something as 1.02 minus 0.965 and 1.03. Again, we calculate the value of x3. In a similar way, if we go to up to uh, this fifth iteration, we get the exact solution, which was achieved through only in second iteration using this approach, previous approach, Gauss-Seidel method. So we have seen that in our previous approach. Let me see this. Up to third iteration, we got the correct answer. And however, in this second approach, that is Jacobi iteration method, you can see that we have to go up to this uh, fourth iteration, and we get the fifth iteration, and we get the uh, 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 up to sixth iteration. You see here that we are going up to this uh, sixth iteration. Then we are able to get the exact answer, which is this fifth or sixth iteration. We get the value of x1 as 1, y1 as minus 1, and z is equal to 1. However, in case of this previous approach, it was only up to third iteration we got the correct answer. So can you solve this question number 6 and make a comment which method will converge more rapidly? Abjit, which method will converge more rapidly? Okay, so you solve this question number 6 using Jacobi iteration method. Any one of you can give the exact answer for this equation 3 unknown? What is the exact answer for this? Let me ask this Deepu Kumar Srivastav. Deepu, what is the exact answer for this? Avantika, can you answer what is the exact answer for this? Three equations, 3 unknown. Then we will use our Jacobi iteration method to compute the exact value and see how many iteration does it takes to get the exact answer. Ritik, Ram Avatar, Shivam, Soumya, any one of you can
Yes,
give
sir.
the
Yes, sir. Already sent.
so what is the exact answer, Soumya?
सर मैंने
X Y
भेज सर भेज दिया है चैट बॉक्स में.
अच्छा ठीक है. But Krishnam is getting the exact answer as 2 minus 1. Abjit is getting okay, ठीक है, okay,
No, sir,
Krishnam.
that one by mistake.
Okay, not that was a mistake. Anyways, so you compute it using this Jacobi iteration method. Okay, many of you have given. Now you solve it using Jacobi iteration method. So first iteration, we will get x1 as 1.119, y1 as 2.808, and z1 as 3.561. Similarly, we will get x2 and y2 and z2. And in a similar manner, if we proceed, we will get our answer as x1 is equal to 1.23, 2.34, and 3.45. So almost all of you gave this answer as correct answer. So you can easily solve it using this Jacobi iteration method. Okay. So this is the graphical representation of the two method, Gauss-Seidel and Jacobi iterative method. In one approach, we use the updated values. However, in second approach, we first compute all the values of unknown, then the updated values are being replaced. So the two approaches are different, but Gauss-Seidel, we have seen that has converged only in third step, where third iteration, where as for a Jacobi iterative method, it went up to sixth iteration. So Gauss-Seidel, we can comment that it has a faster convergence rate. So with this, we will stop here, and anything else we need to discuss which is something which is not clear, you may stay here. Otherwise, class is over. If you wish to leave, you may please leave. So I'll wait for 5 minutes and take your queries.